Hello students, let us start our session with the new chapter number 9, Force and Laws of Motion. Let us first introduce the content. Basically, while the object is available in its original position, that is, it's a rest condition. If it is not moving, we can say it is in the rest condition. While it is moving with its constant velocity, that is, it's a motion condition. Now, if the object is available stationary and we need that object should in motion, then we need to provide some force to it, right? While we are providing the force must be in terms of push, pull or hit. So we can say that to give a force on the object, either of the way we can change the position of the object and we can get in its motion condition. So its initial position, while it is in a rest condition, that condition is known as its a natural state. From its natural state, while we want to get the motion of the object, we need to provide a force in the way push, pull or hit. So we can say that we cannot, while we are providing a force, we can feel the force, right? We can express the force by applying it. By applying that force, we can get the velocity. We can get the magnitude of the velocity, and based on that, direction of the object can change. So while the force is applied, the velocity and the direction may change. So we can say that we can describe the force by its experience, right? While the force is given by the changing in the object, either in the velocity and the direction, we can measure the magnitude of the force which we have applied. By applying the force, we can also change the shape of the object. As a number of examples can seen in the diagram. While in first diagram, we can observe that by applying a force, trolley can move in the particular direction. So here we are giving a pushing force. To open the drawer, we need to give a pulling force, right? And to play a hockey, we need to hit a ball, or we are playing if football, we need to hit a ball. Now, if the spring is there, while we are pulling it from both the sides, then the shape of the spring will change. Or if we are pushing the balloon from both the sides, again the shape of the balloon will change. So here, either we push, pull or hit in which particular direction, accordingly the force can experience. And the velocity of the object can change if it will move further. Now this applied force can be balanced or unbalanced. Let us go through it with the example. As shown in the diagram, one desk is there, one table is there, over which we are putting one object. With that object, at both the opposite ends, we are connecting a string. One end defined as an X and another end is defined as an Y. Now, if we are pulling both the string in opposite direction with the equal force, then object won't move, obviously. I repeat, if we are pulling both the strings in opposite direction, in x and y direction, if opposite and equal force we are providing, object will not move. This force is known as a balance force. But if we are pulling a string in x direction only, then object is supposed to move in that particular direction, in a right direction. And if we are pulling the object in y direction only, then object is supposed to move in left direction. Right? So this is what known as unbalanced force. Now if we are applying pulling force in both the direction x and y, but if these both forces are not same, if the pulling force towards x is more compared to y, then by the difference of the force, object should move in x direction. Or if we are pulling an object with greater force in y direction compared to x, then with the difference of these two forces, object is supposed to move in y direction. So these forces are known as unbalanced force. While we are not providing similar force at both the side, then object is moved from its rest position in the particular direction. So while we are giving the unbalanced force, object gets velocity with the direction in which force is greater. So object is in motion condition. Another example we can take. One box is available on the rough floor. Now children are trying to push that box. Now between the rough floor and the surface of the box, frictional force is available. So one force is available, that is between box surface and rough floor, and another force is applied by the children, that is a pushing force is there. Now initially with the small force, if children are pushing the box is not moving. What does it mean? Frictional force is higher than the pushing force, so object or the box is not moving further. Now if more force is given by the children, even though the box is not moving, again we can say that the given pushing force is lower than the frictional force. Still frictional force is higher. So how much amount of the force is given by the children? Minimum equal to frictional force. If children are giving higher than the frictional force, if the pushing force given by the children is higher than the frictional force, then only the difference of the forces is higher by the children, and then only object is or the box is moving in the particular direction. So object box gets motion in the particular direction by applying a higher force, greater force than frictional force. So here they need to provide unbalanced force. Unbalanced force is necessary to move the object from its rest position, from its natural state. Another examples are there, we can go through it. One bicycle is there that we are paddling continuously. While the paddling is with the constant force and the constant speed. Bicycle is in a motion with the constant velocity. Now in that condition, that object is in a motion with the constant velocity in a particular straight direction. For example, now if we stop pedaling, then what will happen? Bicycle starts to slow down, and after moving in a certain distance with the slower velocity, bicycle will stop to further move. So what is happening over here? Why bicycle is want to move further? Because after stopping the pedaling, frictional force is observed which will be greater compared to the pedaling force between rough surface of the road and tires of the bicycle. So now the frictional force is available which gives the opposite force to the bicycle to the direction of the motion, right? So what we need to do if we want to get a continuous in the motion condition, pedaling should be available to move that bicycle in further motion condition. So we can say that to maintain its a motion condition, continuous unbalanced force is required. Is it so? No. To get in motion continuously, not unbalanced force, but to get a uniform velocity, object moves in a uniform velocity when the pushing force and the frictional force are balanced. If pushing force and frictional force are balanced, then no need to get an external force and object and the bicycle can move with uniform velocity. If unbalanced force is applied, then change of the position of the object may change either in its speed or in its direction. If the velocity is varying, we can say acceleration is there. What is acceleration? Acceleration is nothing but change in the speed divided by time. So the change in the velocity with respect to time, that is the acceleration. So we can say that initial velocity is, for example, u, and if we are providing unbalanced force, then if velocity is changing of the object, so velocity is varying with respect to time, so we can say that now acceleration of the object is available, acceleration of the motion of the object is available while the unbalanced force is applied. So by applying the unbalanced force, its speed and direction we can change, and it will continue until the unbalanced force is applied. Next is Galileo's observation. See, here we are going to learn Newton's law. 3 laws are given by the Newton. Before understanding that Newton's law, we need to understand the Galileo's observation, because Newton's law or Newton observed the condition or the measurements provided by the Galileo, and based on that he was studied further, and then he has given this particular laws of the motion. So before going through it, let us understand Galileo's observation. Here inclined surface is given. While a marble is rolled down from the inclined plane, its velocity is increases. From the top of the inclined surface, while the marble is moving towards the right side, at the downward side, its velocity is increases is shown in the figure A. But if the position of the inclined plane is reversed and marble is supposed to move from left to right in upward direction, in upward inclination direction, then the velocity of the marble is decreases. Right? Two different surfaces are there. Now we are combining both the surfaces, both the inclination angle, and if marble starts to move from left to right in downward inclination and directly it's supposed to move from right in upward inclination direction, then what will happen? Marble is released from left, it is rolling down, so its velocity is higher, and in opposite direction it's supposed to move at upward direction with the same height as it released from. So what will happen? It can reach up to the same direction when the angle in declination and inclination angle is same, then it can reach up to the height from where it started its rolling motion. Now if the inclination of the planes of both the sides are equal, then marble can climb the same distance that is covered from the rolling down. But if the inclination of the right side plane it reduces gradually, then the marble can move further distance till it reaches its original height. Still we are decreasing that particular angle, then again marble move further until the height is supposed to be same. If the inclination we are reducing to the zero, the horizontal slope if we are providing, then marble would continue to travel forever trying to reach the same height, trying to reach at the same height from where it is released. Right? So now what we need to do? We need to provide unbalanced force onto the marble to get its zero condition. So here unbalanced forces on the marble in these cases are zero because it is moving with the constant speed until it reaches, it's supposed to be at the same height, but here we have reduced its height to zero. So marble is moving with the constant velocity continuously. So we can say that here no unbalanced force is there. Right? So here unbalanced force is required to change the motion of the marble, but no net force is needed to sustain its uniform motion. Whatever its uniform motion, constant motion position is there, it will remain continuous. For that, no external force is required. If we want to change its motion condition, then only external unbalanced force is required. But practically, it is not possible. Practically, marble cannot reach, cannot move continuously at infinite distance. So what we can say that here the frictional opposite force is available which can oppose the direction of the motion. So practically marble stops after covering some distance, after traveling some distance due to the frictional force which is the opposite force of the motion of the marble. So effect of the frictional force can be minimized by using smooth marble and smooth surface, smooth plane. And Galileo's observation, which is based on the inclination and declination angle and with the horizontal surface and the frictional force, whatever we have discussed, Newton studied this further with these observations given by the Galileo, and based on that 3 laws of the motion it is given by the Newton, which we'll study further in next part. I hope you have understood the whole session. Thank you.